Hey, welcome to The Explainer. Today we're going to break down some really core principles of object-oriented programming. OOP. The goal here is to help you write code that's cleaner, way safer, and just a lot more powerful. Okay, let's dive right in. So here's our game plan. We're going to start with the why, like what's the fundamental problem with just leaving your data out in the open? And from there, we'll build up, looking at all the tools TypeScript gives us to solve it. We'll cover everything from controlling access to defining code contracts and even managing inheritance. All right, first up, let's talk about why we even bother protecting data inside our classes. It might seem so much easier to just let everything be accessible from anywhere, right? But trust me, that path can lead to some serious chaos down the road. So what's the big deal? Why can't we just let any old part of our code reach in and modify any piece of data it wants? Really, what's the risk here? And this analogy is just brilliant. It really illustrates the core idea perfectly. Just like your body has all these internal systems to protect its temperature, a class should protect its own internal data. You don't want outside interference messing things up, causing bugs, and wrecking the stability of your object. This whole idea, by the way, has a name. It's called encapsulation. Okay, so that's the why. But how do we actually do this? Let's move on to our first technique and see how we can control access using some well-established conventions and a couple of special methods. You see, in traditional JavaScript, there wasn't an actual private keyword for the longest time, so developers came up with a convention, a sort of gentleman's agreement. Sticking an underscore at the beginning of a property name, like _length, was a clear signal to other programmers. Hey, this is for internal use only. Please, don't touch. So if you can't access it directly, how do you even read the value? Well, that's where a getter comes in. Think of it as a controlled read-only gateway for getting that property's value. And to change the value, you use a setter. Now this is where the real power is. The setter is like a bouncer at the door. It gives you the chance to run checks and add protective logic before any change is actually made. Let me give you an example. Without a setter, some other part of your code could just barge in and set a length property to -1. Which makes absolutely no sense, right? But with a setter, you can add a simple check, something like if new value is greater than 0, and just reject any invalid values. It's all about protecting your object's integrity. So now we know how to protect a single class. That's great, but what happens when you have a bunch of different classes that all need to follow the same set of rules? Well, that's where interfaces come into play. You should really think of an interface as a contract for your code. It basically says, hey, any class that wants to sign this contract using the implements keyword is promising, it's guaranteeing that it will have these specific methods and properties. It defines what a class must do, but not how it has to do it. And this is the absolute key takeaway. Implementing an interface is a guarantee. If a class claims it implements something called pingable, it absolutely must have a ping method. If it doesn't, TypeScript will throw an error right away. And that's exactly how we enforce consistency across our entire codebase. Okay, this next bit addresses a point of confusion that trips up a lot of people. So let's take a minute and really clarify the difference between implements, which we just talked about, and another keyword you're going to see everywhere, extends. Let's break it down. Extends is all about inheritance. A dog class extends an animal class, and it gets all of the animal's existing code for free. It's an is-a relationship. But implements is about shape or a contract. A sonar class implements pingable, promising to create its own ping method. It's a can-do relationship. And remember, you can only inherit from one parent class, but you can promise to fulfill multiple contracts. Now, when you inherit from a class using extends, you're not just stuck with its exact behavior. You actually have ways to customize it, and two of the most common ways are overriding and overloading. Overriding is pretty straightforward. It's when a child class redefines a method that it got from its parent. So, for example, the parent animal class might have a greet method, but the dog class that extends it can override that greet method to say woof instead. Same name, same parameters, just a new, more specific behavior. Overloading, on the other hand, is all about flexibility. It's like having a single function name, maybe add, that can behave differently depending on what you give it. It could add 2 numbers or 3 numbers, or it might even be smart enough to concatenate 2 strings if that's what you pass in. Okay, for our final section, let's circle all the way back to where we started, data protection. Remember that underscore convention? Well, TypeScript makes it official with explicit keywords that give us fine-grained control over visibility. Basically, you've got 3 levels. Public is a free-for-all. Anyone can see it and touch it. Private is the complete opposite. It's super strict. Only code inside that exact class can access it. And then protected is that perfect middle ground. The class itself and its children can access it, but nobody else can. And this table just lays out the rules perfectly. Take a close look at that protected column. See how it gets a check mark for within a subclass? That's its special power. It's the ideal way to share data or methods with child classes without making them totally public to the rest of the world.
So the really crucial point here is that none of these concepts work in isolation. They all build on each other. Encapsulation, interfaces, inheritance, visibility. Together, they give you a powerful framework for architecting really complex systems that are actually easy to understand and safe to change later on.
At the end of the day, all these tools are designed to empower you. They give you the confidence to go out and build bigger and better things, because you know your code has a solid, protected, and well-thought-out structure. Thanks so much for joining this explainer.